Have you dealt with wiring or wiring issues with the electrical and you've heard an idiomatic term short or short to ground or many different things, and you're wiring something up, whether it be a ceiling fan, whether it be for a stove, whether it be for a garbage disposal, etc. And you may wonder, what is a short when you've heard electricians talk about a short, and how does it pertain to the real life situation that I'm in or the real life scenario? Very simply, we'll draw a little chicken scratch somatic here and hopefully kind of explain it in layman's terms so the simple mind can actually grasp the concept. And the concept is not that simple. Okay, we have when we're talking electricity may have a path it follows. So it goes from wherever it's got, I'm assuming electrons, I'm not certain. The scientists can add to the comments, but let's just hypothetically say moving from point A to point B. So here, we'll start here. We'll call this the line side for the wire. We've got a wire here, say a number 12 Romex here. So this wire here goes through a juncture box for some reason. Okay, then it goes up here, and we've got a light. We'll call this the light. So we're going to call the light the load. We've got the line, and then we've got the load. Okay, so we've got a path. We've got point A and point B. So this electricity has to go in order to illuminate this light from point A to point B. So we go through this box here. So say hypothetically, we pull this wire through a little hole in this box and we rip the insulation off of the wire. So then once the insulation's ripped off, we're going from point A to point B with the electricity. But the electricity decides it wants to go in a different direction. So bam, we're going in a different direction. So what does it do? Electricity moves according to metal. Some metals are more conductive than others. For instance, copper's a good conductor of electricity, etc. But let's just say it goes to this box. Well, if it goes to this box, then we have a short. So we're not actually getting the full amount of electricity to the load side, which is the light, to illuminate the light, because we've got a path from A to B. And when we go from A to B, we've got a short. So somewhere in between here, say we're going through the woods and we've got a trail here, and we go through this trail, and for some reason we decide we want to take a shortcut. So we go up this trail. Next thing we know, we're lost in the woods. Well, that's kind of an analogy with electricity. We go from point A to point B, but if we tear this insulation, and this insulation, the electrons or whatever makes electricity work, then it wants to jump over here and touch this metal, then it's going in a different direction. So now what happens then? So say, for instance, this were a stove, or this were a some other fixture, and say you came into the kitchen and you did not have a ground wire on it. So what happens if you do not have a ground wire on this? Then say you touch this becomes hot. You could get electrocuted. So this is where it's very important. So when we look in this box here, we see a little green screw here. And we take this wire, this number 12 Romex, a picture of this. This naked wire is the ground wire. So what will happen if we have this attached properly on the green screw with the ground wire with the ground, and we have this grounded, when this metal touches this box, it senses it. It goes back to a different path. And what happens, it shoots back to the breaker box and trips the breaker and cuts it off. An analogy would be cutting the light switch off in a matter of instants. So what happens when we do that? When we do that, this is no longer hot. This is a light, but say it was a stove. Then if the electricity, there's no electricity at all going through here, so this goes to ground. And literally when one says to ground, it will go outside to the breaker box and go outside and maybe go through the electrical. You might find a copper thing driven in the ground, like a piece of metal driven in the ground, and it will go to ground and dissipate into ground. So this, when you hear an electrician talk about a short, this means we're going from point A to point B, but the electricity, for some reason, this insulation gets torn, it gets cut, touches a metal, it shorts, decides it wants to go into a different direction, so it makes it hot. But if we've got a ground screw here, that electricity jumps out here, doubles back, throws the breaker, and we're safe. But if you do not have that, there's two things that could happen. One, you could get shocked. Two, if it's the old wire or wire pulling too many amps, the wire could end up getting hot and melting and create a fire. So when you hear an electrician talking about a short, don't overly complicate the thing. It's very simple. This is, we've got point A on line side going to the light. We'll call the load side. We'll call this point A, point B. The electricity gets cut for some reason, touches metal, it's shorted. So, and then hopefully if it's grounded, then once it's shorted, it will go through the ground wire, trip the breaker, and everything will be fine. You fix the problem, then you throw the breaker, and hopefully it should work fine. So this is a simplistic view for the layman's terms of what an electrical short is and how to understand this concept. If you feel this information is helpful, please share, like, and subscribe, and have a wonderful day.